Elasticity along special demand curves. Suppose we've got a demand equation given by Q equals 200p to the negative 0.5. Let's find the price elasticity of demand when the price is 30 and when the price is $10. Now we should recognize right away this is a constant elasticity of demand curve, which means it's going to have an elasticity of negative 0.5 all along the demand curve. Now where did I get that negative 0.5? It's the coefficient on P. So when demand takes this form, a coefficient times P raised to an exponent, the exponent is going to be your price elasticity of demand. We can derive that though. Elasticity is going to be the derivative of quantity with respect to price times price over quantity. So here's my quantity equation, my demand equation. If I partially differentiate it with respect to price, I'll get 200 times negative 0.5 p to the negative 1.5. Or simplifying, it's a negative 100 p to the negative 1.5. I'm going to take that and plug in for the first part of my expression. So elasticity equals the negative 100 p to the negative 1.5 times p over q. I'm going to plug in for Q, and I'm going to just use my original demand equation. So rewriting, I have that negative 100 p to the negative 1.5 times p over 200 p to the negative 0.5. I'm going to rewrite this one more time just so it looks a little cleaner. So my numerator is negative 100 times p to the negative 1.5 times p. And my denominator is 200 times p to the negative 0.5. Well, I can see I can do some simplifying. That negative 100 over 200, it's going to simplify to a negative 1/2. And then I can combine these p's. Well, there's really an implicit 1 hanging out here on this p. So the numerator is really p to the negative 0.5, right? Negative 1.5 plus 1 is a negative 0.5. Well, now my numerator and denominator are going to cancel out, leaving me with an elasticity of negative 0.5. So if you recognize your demand equation is a constant elasticity form, all you need is the exponent on price and you know your elasticity. Let's suppose we've got demand where it's Q equals 400 minus 10p. Let's calculate price elasticity of demand when price is 30 and when price is 10. Well, we recognize this is a linear demand curve, and a linear demand curve always has elasticity given by negative b times p over q. B is always the coefficient on p. So in this case, we've got negative 10. I just pulled that directly out of my demand equation. So when price is 30, I plug in the negative 10 for b, the 30 for price, and I still have that Q term remaining. Well, if I take my original demand equation and I plug in 30 for price, out will come the quantity that I should plug in. Now all it's left to do is simplify and find out when price is 30, the elasticity of demand is a negative 3. In other words, when price is $30, demand is elastic. When price is $10, we'll do the same procedure. We'll plug in the negative 10 for B, that hasn't changed. We'll plug in 10 for price, and now we'll have to find quantity. Going back to my original demand equation, I'll plug in 10 for price. I'll find that at that price quantity is 300. I'll substitute that back into my elasticity formula. I'll simplify, and I'll get when price is $10, elasticity of demand is negative 0.33. In other words, when price is $10, demand is inelastic. In general, on our linear demand curve, the elastic range is up towards the top and the inelastic range is down towards the bottom.